Hey everybody, I'm Sydney and I'm going to talk about emphysema. In order to understand emphysema, we need to understand the tissues involved. So start in the lung. So here I've drawn a picture of the lung. As you can see, there's a big trachea here, also known as your windpipe. And that branches down into smaller and smaller bronchi and then bronchioles. And then at the end of the bronchioles are these little clusters of alveoli. I know those are all fancy words, but there's the alveoli in there. And each lung has about 250 million alveoli, which is great for us because it makes us great at thinking and running and performing functions in our body. We need all that oxygen to do work, and we need to get rid of the CO2 from doing that work. And it all happens here and at the capillary bed surrounding these alveoli. So let's take a little closer look at one of these alveoli. So a single one is an alveoli, and then a cluster of them is an alveolar sac, like this right here. But we'll start here. So here's an alveoli. It has this really thin tissue around it. It's called simple squamous epithelium. So simple in anatomy or physiology just means a single layer, and squamous is I just remember the cell as being a squished or flat cell. And that's a great design for gas exchange. If this cell was a big, beefy mucus cell or something like that, gas wouldn't be able to pass through it. So this is perfect. This is the perfect tissue for the lungs. So if we there's the one single alveoli, and here's the simple squamous. So this is what it would look like from a bird's eye view. It looks a little bit like a fried egg. And if we cut it in half like this pink line suggests, and we looked at it in cross section, it looks like this, nice and skinny. And you can see it again here, like I've drawn. And then a cluster of these structures together is the alveolar sac. And they're each round. They're round like grapes, so it does look like a cluster of grapes down there, kind of, and that's a super great design because if it was just a big blob, it wouldn't have all this great surface area. So if you can imagine, you've got an alveoli here, and another one here, and another one here, off to the numbers of 250 million per lung, you have just this great opportunity for all this gas exchange because of this amped up surface area that's happening with this design. So now let's go in and see what happens with some gas exchange. So we'll go and we'll look at the alveoli. Here's one, here's another one, and so forth and so on. And then down here I've drawn a little capillary. So you can imagine this capillary is about the width of a single red blood cell. It's pretty small when it gets down around these tissues. And it's composed of simple squamous cell as well. So I've drawn it blue here just to denote that this is an alveolar sac in cross section. And then down here, I've drawn it in pink, but they're the same tissue. This is a simple squamous cell, just like this one. And again, that design is great for gas exchange. So when we take a deep breath, our bronchioles are going to bring oxygen down into these sacs, and it's just going to easily pass through this thin cell. So the oxygen is going to make its way into this space. And then, at the same time, your blood is like, whoa, I don't have a whole lot of oxygen, but I got a ton of carbon dioxide. Let's do a trade. So you've got the CO2 traveling in here. Maybe some of it's traveling on the red blood cell itself. Some of it's maybe floating around in there. And when we breathe in, we bring in that oxygen. Some pressure changes happen. One space has too much of something and the other one doesn't have enough. And so they switch places, and the CO2 is going to migrate through this thin cell and make its way out in breath. So we exhale that, and it's just expelled from our lungs. It's an amazing system. It's super efficient, and it works for 80, 90, 100 years, so we're lucky to have it. All right, so this word up here is etiology. It's a fancy word for cause of disease, and so for emphysema, the leading cause of disease in first world countries is smoking. We all know smoking is bad for us. It's expensive, it's addictive, it causes damage over time. And then in third world countries, certainly people smoke in third world countries as well, but the leading cause of emphysema in third world countries is pollutants. So that could be that you're working in an unhealthy workspace, or you're living in a region of the world that's highly populated with poor EPA standards and air quality standards and all that. So these two items lead to problems in the lungs. All right, so how does our body respond to all those pollutants and particulates? Well, it gets irritated. The body identifies that there's some problem in our lungs, there's that debris in there, and our immune system is like, whoa, we got a problem, we've got something here that doesn't belong. So our immune system is just this amazing system that keeps us going. So it helps us recover from the common cold and big problems and little problems. we have cells in our body that identify a threat, and they work together to eliminate the threat by phagocytosis. And then there's another component of that that actually remembers what the threat looks like, and so catches it before it can become a problem if we ever get exposed to it again. But in the case of emphysema, what's happening is we're getting prolonged exposure to particulate matter. So in this case, it's debris, and it's ongoing. So our body is constantly working in this state of immune response, and that leads to inflammation. And inflammation in the short term is great. It keeps us going. Like I said, it fights disease and common cold and whatnot. But over the long run, it can cause damage to the very tissue that it's trying to protect. So there's some mechanisms in there that are just deleterious to tissue over time. So one of the problems is we have these phagocytes, and they're great, like I said, short term. And phagocyte is just a fancy word for, well, phag means eat, and cytes is a fancy word for cells. So these cells are eater cells, and what they do is they're like, well, I've identified some debris in here. I'm going to go in and clean it up. I'm going to go in and get that pollutant from smoking or from working in an unhealthy workplace, and I'm going to eat it up with some enzymes. It doesn't actually eat it, but it does engulf it or ingest it in a way. And those enzymes, the byproduct of that phagocytosis, creates some damage to the tissues around it. And that a little bit of damage is no big deal, but damage over 10 years, 20 years, then we've got a problem, because our body responds to damage by bringing in new tissue. And we're like, oh, this will cut our arm, for example, or a leg. Maybe we've got a doozy of a scar and a story behind it. But the tissue that replaces the tissue that was damaged is scar tissue, and scar tissue doesn't necessarily do the same function, or not at all. It doesn't grow hair, it doesn't produce sweat glands, it doesn't produce oil glands. It's just kind of this gap measure that closes the skin. And it's kind of like that in the lung too. So over time, our cells, our simple squamous cells that we talked about being so delicate, they get damaged, and those enzymes wreak some havoc on them, and they start to deteriorate. So they break down. These walls of this alveolar sac start to break down, disintegrate. And if they are replaced, they're replaced by something that's more fibrous, that doesn't have the same elasticity, it's more rigid, doesn't have the same give. And we have all these connecting walls in between these alveoli, and they offer surface area for gas exchange. But when we lose them, because they get degraded over time by these enzymes, then we lose a lot of that surface area, and so our ability to exchange gas is diminished. And then also because we've brought in this scar tissue rather here, that doesn't have the same elasticity of these simple squamous cells, we're not getting the recoil. So let's talk about that a little bit. So we've all done this trick where we've taken a rubber band and we stuck it on our finger and we shoot it across the room at our friend, and they laugh because we miss them. And that the reason that snaps is because of the recoil in the rubber. So these cells have had a lot of recoil. So they were able to, when you breathe in, it kind of expands, and then they return to their regular size. And then that's the part that expels the carbon dioxide out of our body. So gas exchange is limited in here. And then also, another problem with that, because it doesn't have that elastic recoil, carbon dioxide is starting to accumulate in these alveolar spaces. And that's a problem, because that leads to acidosis in the body, and I'll go over that a little bit more in a minute. And then there's another component to all of this. Sometimes we inherit genes, well, not sometimes, every time an organism is created, right, we're getting the genes from our parents, and some of us inherit a gene called A1AT, which is alpha-1 antitrypsin, and that gene can make you more susceptible to the damaging effects of these enzymes that are a result of phagocytosis. So if you happen to live in that third world country with poor air quality standards, or if you happen to become addicted to smoking and you end up having these pollutants over time, you have really increased your odds of developing emphysema. And while it's not a guarantee that you will, your odds are increased. And it's not very often that you can be exposed to these things in the long term and not develop complications in the lungs, be it chronic bronchitis or asthma or whatnot. So it's really important that we take care of our delicate tissues to the best of our abilities.